ดีค่ะ
สวัสดีครับ Good morning
สวัสดีแล้วก็ต้อนรับท่านผู้มีเกียรติที่เคารพทุกท่านอีกครั้งหนึ่งนะคะดิฉันปัทมาเนียมบดีค่ะนักประชาสัมพันธ์ชำนาญการจากงานประชาสัมพันธ์และมวลชนสัมพันธ์ค่ะ
And I am Warren Pisit Yusri, a lecturer of English and Linguistics from the Faculty of Humanities and Social Sciences, Yala Rajpat University.
เรียนท่านประธานท่านผู้บริหารมหาวิทยาลัยราชภัฏยะลาท่านวิทยากรผู้ทรงคุณวุฒินะคะคณะทำงานเครือข่าย7หน่วยงานในวันนี้ค่ะและผู้เข้าร่วมประชุมทุกท่านต้อนรับทุกท่านค่ะเข้าสู่งานประชุมวิชาการนานาชาตินะคะ AWIS 2026 ค่ะ
Ladies and gentlemen, distinguished administrators of Yala Rajpat University, speakers, administrators, guests, and members of the organizing committees. Ladies and gentlemen, it's my great pleasure to welcome you to the first AgriWell International Conference, or AWIS 2026, under the themes Advancing Agriculture and Wellness by Innovation.
ค่ะสำหรับวันนี้นะคะก็จะมีคณะทำงานนะคะเครือข่ายร่วมกันนะคะ7เครือข่ายด้วยกันค่ะซึ่งประกอบไปด้วยนะคะมหาวิทยาลัยราชภัฏยะลาค่ะมหาวิทยาลัยแห่งชาติคยองคุกนะคะมหาวิทยาลัยสุลต่านไซนัตอาบีดินค่ะมหาวิทยาลัยเชียงใหม่มหาวิทยาลัยพะเยามหาวิทยาลัยเกษตรศาสตร์นะคะและสถาบันเทคโนโลยีพระจอมเกล้าเจ้าคุณทหารลาดกระบังค่ะ
Ladies and gentlemen, this conference is a collaborative initiative among 7 partner institutions, including Yala Rajpat University, Thailand, Gyeongguk National University, Republic of Korea, University Sultan Sano Abidin, Malaysia, Chiang Mai University, Thailand, the Universities of Payao, Thailand, Kasetsart University, Thailand, and King Mongkut Institute of Technology, Lat Krabang, Thailand.
ค่ะและในลำดับต่อไปนะคะขอเรียนเชิญทุกท่านนะคะร่วมยืนสงบนิ่งเพื่อถวายความอาลัยและน้อมรำลึกในพระมหากรุณาธิคุณอันหาที่สุดมิได้แด่สมเด็จพระนางเจ้าสิริกิติ์พระบรมราชินีนาถพระบรมราชชนนีพันปีหลวงและสมเด็จพระเจ้าลูกเธอเจ้าฟ้าพัชรกิติยาภานเรนทิราเทพยวดีกรมหลวงราชสารินีสิริพัฒน์มหาวชิรราชธิดาเป็นเวลา1 นาทีค่ะ
Ladies and gentlemen, at this time, my colleagues invite everyone to please stand for a moment of silence to pay respect our deepest and profound remembrance and gratitude for the immeasurable contributions of Her Majesty Queen Sirikit, the Queen Mother, and Her Royal Highness Princess Pacharakitiyapha Narendra Thepayawadi. May I kindly ask everyone to remain standing for the moment of silence.
ขอขอบคุณทุกท่านเป็นอย่างสูงค่ะขอเชิญทุกท่านนั่งลงตามอัธยาศัยค่ะ
Please be seated.
ค่ะและในลำดับต่อไปนะคะจะขอเชิญทุกท่านค่ะรับชมวิดีทัศน์นำเสนอภาพรวมของงานประชุมวิชาการและการแสดงศิลปะวัฒนธรรมนะคะยุทธลีลาศาสตรามาลายูค่ะโดยศูนย์ศิลปะวัฒนธรรมสถาบันวิจัยและพัฒนาชายแดนภาคใต้มหาวิทยาลัยราชภัฏยะลาค่ะร่วมกับมหาวิทยาลัยการกีฬาแห่งชาติวิทยาเขตยะลาค่ะ
Ladies and gentlemen, first we would like to invite everyone to watch a short video presenting an overview of the conference. Following the video, we will have the pleasure of witnessing a traditional cultural martial arts. We call it Malay martial arts performance by the Arts and Culture Center, Yala Rajpat University, in collaboration with Thailand National Sport University, Yala Campus. That is a part of the Creative Research Project in 2026.Ladies and gentlemen, please sit back, relax, and enjoy the videos and Panchak Silat cultural performance.
ราชภัฏสมญานามประธานศักดิ์สถานสำคัญการศึกษา
Rajabat University, people of the king, servants of the land. For more than 90 years, Yala Rajabat University has been serving our community. We have grown alongside Thailand's Deep South, evolving with the communities we serve and adapting to the changes and challenges of each era. From a teacher training school to a teacher's college to a Rajabat Institute, and today as Yala Rajabat University. Our journey reflects more than 90 years of transformation. It is a testament to our enduring commitment to expanding educational opportunities and nurturing quality graduates for our community. We believe that quality graduates are not defined solely by their academic performance in the classroom. They must also possess essential future skills, including practical skills, creativity, critical thinking, collaboration, and adaptability. With more than 60 academic programs spanning a wide range of disciplines, Yala Rajabat University is powered by the collective strength of 6 faculties: the Faculty of Education, the Faculty of Humanities and Social Sciences, the Faculty of Science, Technology, and Agriculture, the Faculty of Management Sciences, the Faculty of Public Health and Allied Health Sciences, and the Faculty of Nursing. Our educational offerings span all levels, from certificate programs and undergraduate degrees to master's and doctoral programs, as well as lifelong learning opportunities. Beyond higher education, Yala Rajabat University also provides educational opportunities from early childhood and kindergarten through primary and secondary education through its demonstration school. Yala Rajabat University is committed to achieving global standards and advancing toward international recognition. We are ready to strengthen partnerships both nationally and internationally, connecting knowledge, research, and innovation to create meaningful value and contribute to the global community. At Yala Rajabat University, communities and localities are at the heart of our mission and a cornerstone of sustainable development. We turn knowledge, research, and innovation into practical solutions that create meaningful change across Thailand's Deep South. From the potential of our researchers to innovations and intellectual property that create economic value, we strive to drive sustainable growth while enhancing the quality of life and strengthening the resilience of local communities. We create modern and inspiring learning spaces that nurture holistic well-being, both physically and mentally. Our goal is to make the university a place where learning is joyful, growth is meaningful, and everyone can thrive. At the same time, we have a mission to become a green university. We embrace clean energy through solar power, promote electric transportation across our campus, and expand green spaces that help absorb carbon emissions. These efforts reflect our responsibility to protect the environment and create a more sustainable future for generations to come. We drive our organization forward through digital technology and artificial intelligence, AI, aspiring to become a leading hub for AI technology in Thailand's Deep South, while building an ethical, transparent, and well-governed organization that promotes fairness, equity, and equality across all dimensions. This is our more than 90-year journey, a journey that has been built on a foundation of pride.
ขอบคุณสำหรับเสียงปรบมือด้วยนะคะที่จบลงไปค่ะเป็นการแสดงในพิธีเปิดนะคะยุทธลีลาศาสตรามาลายูค่ะโดยศูนย์ศิลปะวัฒนธรรมสถาบันวิจัยและพัฒนาชายแดนภาคใต้มหาวิทยาลัยราชภัฏยะลานะคะร่วมกับมหาวิทยาลัยการกีฬาแห่งชาติวิทยาเขตยะลาค่ะซึ่งการแสดงชุดนี้นะคะก็จะเป็นผลงานวิจัยสร้างสรรค์ประจำปีพุทธศักราช 2569 นะคะของศูนย์ศิลปะวัฒนธรรมสถาบันวิจัยและพัฒนาชายแดนภาคใต้มหาวิทยาลัยราชภัฏยะลาร่วมกับมหาวิทยาลัยการกีฬาแห่งชาติวิทยาเขตยะลานั่นเองค่ะ
Ladies and gentlemen, this is the Malay martial arts performance by the Arts and Culture Center, Yala Rajpat University, in collaboration with Thailand National Sport University, Yala campus. And that is a part of the Creative Research Project in 2026.
ค่ะและในลำดับต่อไปนะคะก็จะนำท่านผู้มีเกียรติที่เคารพทุกท่านนะคะเข้าสู่พิธีเปิดงาน AWIS 2026 อย่างเป็นทางการค่ะ
Ladies and gentlemen, we have now arrived at this auspicious moment, and it is my great pleasure to officially begin the opening ceremonies of AWIS 2026.
ในโอกาสนี้นะคะขอเรียนเชิญผู้ช่วยศาสตราจารย์ดรสุริชัยนามบุรีอธิการบดีมหาวิทยาลัยราชภัฏยะลาค่ะได้ให้เกียรติขึ้นกล่าวต้อนรับพร้อมรายงานถึงวัตถุประสงค์ของการจัดงานประชุมวิชาการนานาชาติในครั้งนี้ค่ะ
May I respectfully invite Assistant Professor Dr. Sirichai Namburi, President of Yala Rajpat University, to deliver the welcome address and present the objectives of this international conference. Ladies and gentlemen, please join me in welcoming Assistant Professor Dr. Sirichai Namburi.
Distinguished keynote speakers, honorable guests, international and Thai researchers, teachers, students, ladies and gentlemen, good morning and Sawadee Krab. On behalf of Yala Rajpat University, it is my great pleasure to warmly welcome all of you to the first AgriWell International Symposium 2026 or AWIS 2026 under the theme Advancing Agriculture and Wellness by Integrated Science, Technology and Innovation. We are truly delighted to welcome distinguished scholars, researchers, professionals, teachers, and students from Thailand and abroad to Yala Rajpat University. This year, AWIS 2026 brings together 32 research papers, including 18 domestic and 14 international papers. We are especially honored to welcome international presenters from 6 countries, including South Korea, Taiwan, India, Japan, Malaysia, and Indonesia. Your participation reflects the spirit of AWIS as a platform for exchanging knowledge, building academic networks, and strengthening international collaboration in agriculture, science, technology, and innovation. For Yala Rajpat University, hosting this international symposium is particularly meaningful as a university committed to local and regional development. And we believe that connecting local knowledge with global expertise can create new opportunity and contribute to sustainable development and a better quality life for our communities. I am also very pleased that AWIS 2026 provides a platform for the next generation of innovators through the AgriWell Inventor Award 2026. This year, we have 46 senior high school student teams are participating in the innovation and invention competition. So with 15 teams in agriculture and materials and 31 teams in health and medical science. To all of you young innovators, I hope this experience inspires you to be curious, creative, and confident to develop your ideas. Today is not only about winning in award, but also about learning, sharing, and taking an important step toward your future. To our international guests, welcome to Yala Province, Thailand. Welcome to Yala Ratchapat University. We hope that your time here will bring you not only valuable academic experiences, but also new friendship and memorable experiences of hospitality and cultural diversity of Thailand's southern border region. And finally, I would like to express my sincere appreciation to our distinguished speaker, presenter, partner institution, participating schools, teachers, students, organizing committee, and everyone who has contributed to making AWIS 2026 region possible. Once again, welcome to AWIS 2026. I wish you all a productive, inspiring, and memorable conference at here. Thank you very much. ขอบคุณมากครับ สวัสดีครับ
ค่ะก็ต้องขอบคุณผู้ช่วยศาสตราจารย์ดรสิริชัยนามบุรีอธิการบดีมหาวิทยาลัยราชภัฏยะลานะคะที่ได้ให้เกียรติกล่าวต้อนรับพร้อมรายงานถึงวัตถุประสงค์ของการจัดงานประชุมวิชาการนานาชาติในครั้งนี้ขอบคุณอีกครั้งหนึ่งค่ะ
Thank you very much, Assistant Professor Dr. Sirichai Namburi, for your welcome and presenting the objectives of the conference.
ค่ะและในลำดับต่อไปนะคะก็จะเป็นการกล่าวเปิดงานนะคะในโอกาสนี้ขอเรียนเชิญท่านจรัญบำรุงเสนาผู้ช่วยเลขาธิการศูนย์อำนวยการบริหารจังหวัดชายแดนภาคใต้ค่ะได้กล่าวเปิดงานประชุมวิชาการนานาชาติ AWIS 2026 อย่างเป็นทางการค่ะ
Ladies and gentlemen, we will now proceed to the opening address. On this special occasion, may I respectfully invite Mr. Jaran Bamrung Sena, Assistant Secretary General of the Southern Border Provinces Administrative Center, Department of Public Relations, to deliver the official opening address of the first AgriWell International Conference, AWIS 2026. Ladies and gentlemen, please join me in welcoming Mr. Jaran Bamrung Sena.
เรียนท่านรองผู้ว่าราชการจังหวัดยะลาท่านอธิการบดีมหาวิทยาลัยราชภัฏวิทยากรผู้ทรงคุณวุฒิแขกผู้มีเกียรตินักวิจัยนักวิชาการคณาจารย์นักเรียนนักศึกษาและก็ผู้ร่วมงานทุกท่านนะครับ สวัสดีครับก็นับเป็นเกียรติอย่างยิ่งครับที่ผมได้มาเป็นประธานในพิธีเปิดการประชุมวิชาการนานาชาติ The First AgriWell International Symposium 2026 หรือ AWIS 2026 ภายใต้แนวคิด Advancing Agriculture and Wellness by Integrating Science, Technology and Innovation หรือการยกระดับการเกษตรและสุขภาวะด้วยการบูรณาการวิทยาศาสตร์เทคโนโลยีและนวัตกรรมการจัดประชุมวิชาการในครั้งนี้นับเป็นโอกาสสำคัญไม่เพียงสำหรับมหาวิทยาลัยราชภัฏเท่านั้นแต่ยังมีความหมายต่อจังหวัดยะลาและพื้นที่ในจังหวัดชายแดนภาคใต้ ซึ่งเป็นพื้นที่ที่มีศักยภาพด้านทรัพยากรทางการเกษตร ความหลากหลายทางชีวภาพ ภูมิปัญญาท้องถิ่น และความหลากหลายทางวัฒนธรรมอันเป็นต้นทุนสำคัญที่สามารถนำมาต่อยอด เพื่อการพัฒนาพื้นที่ได้อย่างยั่งยืน อย่างไรก็ตามท่ามกลางศักยภาพดังกล่าว พื้นที่ยังคงเผชิญกับความท้าทายในหลายมิติทั้งด้านการเกษตร สุขภาพ เศรษฐกิจ และคุณภาพชีวิตของประชาชน การนำวิทยาศาสตร์เทคโนโลยีและนวัตกรรมมาประยุกต์ใช้ให้สอดคล้องกับบริบทความต้องการของพื้นที่ จึงเป็นกลไกที่สำคัญที่จะช่วยเพิ่มพูนให้แก่ทรัพยากรในท้องถิ่น สร้างโอกาสทางเศรษฐกิจ และนำไปสู่การยกระดับคุณภาพชีวิตของประชาชนอย่างเป็นรูปธรรม ด้วยเหตุนี้การจัดงาน AWIS 2026 ณ มหาวิทยาลัยราชภัฏยะลาจึงมีความสำคัญอย่างยิ่งในการเป็นเวทีเชื่อมโยงโจทย์และศักยภาพของพื้นที่เข้ากับองค์ความรู้และความเชี่ยวชาญในระดับสากล เปิดโอกาสให้นักวิจัย นักวิชาการ ผู้เชี่ยวชาญ นักเรียน นักศึกษา และผู้ที่เกี่ยวข้องได้ร่วมแลกเปลี่ยนองค์ความรู้ ประสบการณ์ และแนวคิดตลอดจนสร้างเครือข่ายความร่วมมือทางวิชาการทั้งในประเทศและก็ต่างประเทศ ผมเชื่อมั่นว่าการแลกเปลี่ยนองค์ความรู้ที่เกิดขึ้นในวันนี้จะไม่สิ้นสุดเพียงการนำเสนอทางวิชาการ แต่ก็จะเป็นจุดในการเริ่มต้นของความร่วมมือด้านการวิจัย การพัฒนานวัตกรรม การองค์ความรู้ไปประยุกต์ใช้ให้เกิดประโยชน์ต่อพื้นที่ โดยเฉพาะการพัฒนาด้านการเกษตรและสุขภาวะ ซึ่งเป็นประเด็นสำคัญที่เชื่อมโยงโดยตรงกับวิถีชีวิต การพัฒนาคุณภาพชีวิตของพี่น้องประชาชน ในโอกาสนี้ผมขอขอบคุณมหาวิทยาลัยราชภัฏสถาบันและหน่วยงานเครือข่าย วิทยากร ผู้ทรงคุณวุฒินักวิจัย นักวิชาการ คณาจารย์ นักเรียน นักศึกษาตลอดจนคณะกรรมการจัดงานทุกท่านที่ได้ร่วมกันกับเคลื่อนให้การประชุมวิชาการนานาชาติในครั้งนี้เกิดขึ้นและเป็นอีกก้าวหนึ่งในการเปิดพื้นที่จังหวัดชายแดนภาคใต้สู่การแลกเปลี่ยนองค์ความรู้และความร่วมมือทางวิชาการในระดับนานาชาติผมหวังเป็นอย่างยิ่งว่า AWIS 2026 จะเป็นเวทีที่เชื่อมโยงศักยภาพของท้องถิ่นกับองค์ความรู้ระดับสากลและนำองค์ความรู้จากการแลกเปลี่ยนในวันนี้ไปสู่การสร้างคุณค่าและการพัฒนาที่ยั่งยืนในอนาคตต่อไปบัดนี้ได้เวลาอันสมควรแล้วผมขอเปิดการประชุมวิชาการนานาชาติ The First AgriWell International Symposium 2026 อย่างเป็นทางการขออำนวยพรให้การจัดงาน AWIS 2026 บรรลุวัตถุประสงค์และประสบความสำเร็จทุกประการขอบคุณครับ
ค่ะก็ต้องขอบคุณนะคะท่านประธานในพิธีในวันนี้กันด้วยนะคะที่ได้ให้เกียรติกล่าวเปิดงานอย่างเป็นทางการในครั้งนี้ค่ะและอีกสักครู่หนึ่งนะคะจะได้รายงานนะคะเป็นภาษาอังกฤษอีกครั้งหนึ่งค่ะขอเรียนเชิญค่ะ
Ladies and gentlemen, as the welcome address in Thai, may I kindly ask your permission to interpret his welcome address in English. Ladies and gentlemen, he started to express his great honor in presiding over the opening ceremony for the first AgriWell International Conference, or AWIS 2026. And he noted that the conference is not only important for Yala Rajpath University, but also for the Yala province and Thailand's southern border regions. And he highlighted that the region is rich in cultural resources, biodiversity, local wisdom, and cultural diversity. At the same time, he acknowledged that the regions continue to face challenge of agriculture, health, and economic development and qualities of lives of the peoples of in the deep south of Thailand. And he emphasized that applying science, technology, and innovation in ways that we respond to the local needs and context is essential. He also explained that hosting AWIS 2026 at Yala Rajabhat University was particularly meaningful because the symposium provided a platform to connect the local challenges and the global perspectives and potential with the global researchers' expertise. It is also creates opportunity for researchers, academics, and expert teachers, and also the students of Yala Rajabhat University and the students in the Deep South region, and all stakeholders to exchange knowledge and experience, share ideas, and strengthen academic networks and collaboration, both in national and international level. And lastly, he also expressed his sincere appreciation to Yala Rajabhat University, partner institutions and organizations, speakers, researchers, academics, researchers, students, and the committees for their valuable contribution to making this international conference possible. Finally, he concluded that AWIS 2026 would serve as a platform where local potential could connect with the global knowledge, and where the knowledge exchange would be transformed into meaningful value and sustainable development for society. And finally, he formally declared the first AgriWell International Symposium 2026 open, and which the symposium very success in achieving its objectives. Thank you very much.
ค่ะและในลำดับต่อไปนะคะท่านประธานอยู่ด้านบนเวทีแล้วนะคะเรียนเชิญมหาวิทยาลัยราชภัฏยะลานะคะผู้ช่วยศาสตราจารย์ดรสุริชัยนามบุรีค่ะมหาวิทยาลัยแห่งชาติขยองคุกนะคะมหาวิทยาลัยสุลต่านไซนัตอาบีดินค่ะมหาวิทยาลัยเชียงใหม่มหาวิทยาลัยพะเยามหาวิทยาลัยเกษตรศาสตร์และสถาบันเทคโนโลยีพระจอมเกล้าเจ้าคุณทหารลาดกระบังด้านบนเวทีค่ะ
Ladies and gentlemen, may I invite our partner from Yala Rajabhat University, Kyongkuk National University, University Sultan Sainon Abidin, Chiang Mai University, the University of Payao, Kasetsat University, and King Mongkut Institute of Technology, Lat Krabang, come up on the stage for the opening ceremony.
ค่ะทั้ง7หน่วยงานนะคะด้านบนเวทีพร้อมด้วยท่านประธานและแล้วนะคะช่วงเวลาที่สำคัญที่สุดนะคะของพิธีเปิดงานประชุมวิชาการนานาชาติ AWIS 2026 นะคะก็จะเริ่มต้นขึ้นค่ะรอด้านบนเวทีอีกสักครู่หนึ่งนะคะด้านบนเวทีพร้อมในหอประชุมแห่งนี้พร้อมนะคะเราจะร่วมนับถอยหลังนะคะสร้างประวัติศาสตร์ในวันนี้ไปพร้อมๆกันค่ะสำหรับพิธีเปิดงานประชุมวิชาการนานาชาติ AWIS 2026 ถ้าพร้อมแล้วนะคะร่วมนับถอยหลังไปพร้อมๆกันค่ะ
3, 2, 1.
ช่วงเวลาที่สำคัญในวันนี้นะคะต้อนรับทุกท่านเข้าสู่ AWIS 2026 ค่ะรวมสร้างประวัติศาสตร์หน้าใหม่และปักหมุดความสำเร็จครั้งยิ่งใหญ่ให้แก่มหาวิทยาลัยราชภัฏยะลาค่ะ
Ladies and gentlemen, welcome everyone to the first AgriWell International Conference or AWIS 2026 under the theme Advancing Agriculture and Wellness by Integrating Science, Technology and Innovation.
เรียนเชิญแถวแรกนะคะด้านบนเวทีนะคะเพื่อถ่ายภาพร่วมกันนะคะในพิธีเปิดอย่างเป็นทางการค่ะสำหรับงานประชุมวิชาการนานาชาติ AWIS 2026 ด้านบนเวทีขอเรียนเชิญค่ะเรียกได้ว่าวันนี้เราร่วมกันสร้างประวัติศาสตร์หน้าใหม่นะคะแล้วก็ปักหมุดความสำเร็จครั้งยิ่งใหญ่ให้แก่มหาวิทยาลัยราชภัฏยะลาอีกครั้งหนึ่งค่ะครั้งนี้เป็นครั้งแรกนะคะ
At this time, may I colleagues invite the university administrators, members of organizing committees and designated speakers to join on the stage for group photos.
ซึ่งวันนี้ได้รับเกียรติจากท่านผู้มีเกียรติที่เคารพนะคะทั้งในส่วนของจังหวัดยะลาโดยท่านรองผู้ว่าราชการจังหวัดยะลานะคะ ท่านวีรพัฒน์บุญธริกได้ให้เกียรติมาร่วมด้วยในวันนี้รวมไปถึงตัวแทนจากสบตนะคะท่าแรกค่ะขอท่า YRU ค่ะสัญลักษณ์มหาวิทยาลัยราชภัฏยะลาค่ะ YRU มือขวานะคะขอมินิฮาร์ท1ภาพค่ะกดไลค์1ภาพค่ะ Thank you very much ขอบคุณค่ะขอบคุณค่ะ
Thank you very much
ท่านประธานยังอยู่ด้านบนเวทีนะคะเดี๋ยวเรียนเชิญแถวที่2ค่ะถ่ายภาพร่วมกันด้านบนเวทีขอเรียนเชิญค่ะ
So may I invite the participants on the second row to come up on the stage for the photo session.
ขอบคุณท่านผู้มีเกียรติแถวแรกอีกครั้งหนึ่งนะคะค่ะก็จะเป็นผู้บริหารมหาวิทยาลัยนะคะหัวหน้าส่วนราชการในพื้นที่จังหวัดชายแดนภาคใต้นะคะภาพนี้ก็จะเป็นอีกหนึ่งภาพใหญ่ในวันนี้นะคะที่จะสร้างประวัติศาสตร์หน้าหนึ่งในงานประชุมนานาชาติของเรา AWIS 2022 ค่ะเช่นเดียวกันนะคะท่าแรกขอ Signature YRU ค่ะมือขวานะคะขอบคุณค่ะขอมินิฮาร์ท1ภาพค่ะโอเครอยิ้มให้ท่านอธิการบดีค่ะที่แก้ม1ภาพนะคะขอรอยยิ้มส่งกำลังใจให้กับทีมงานวันนี้นะคะประสบความสำเร็จสำหรับครั้งแรกในการสร้างประวัติศาสตร์หน้าใหม่แล้วก็ปักหมุดที่นี่เลยนะคะขอบคุณทุกท่านค่ะภาพน่ารักมากขอบคุณค่ะขอบคุณค่ะ
Thank you very much, everyone. You may now return to your seat, please.
ขอบคุณท่านผู้มีเกียรติที่เคารพนะคะแถว2อีกครั้งหนึ่งค่ะลำดับต่อไปนะคะเราจะเข้าสู่ในช่วงของการบรรยายพิเศษนะคะจากคีโนตในวันนี้ทั้ง4ท่านด้วยกันนะคะก็เรียนเชิญอาจารย์บิ๊กค่ะ
Ladies and gentlemen, we will now proceed to the first keynote speech entitled Insects are the Vital Resource for Green Bioindustry. It is a great honor to welcome Professor Dr. Chu Lei-jung from Gyeongguk National University, Republic of Korea. Professor Chu Lei-jung is a professor in the Department of Plant Medicals at Gyeongguk National University, Republic of Korea. And he formerly serves at Andong National University. He specializes in insect ecology, apiculture, pollination, integrated pollinator, and pest management. Professor Chung received his Bachelor of Science in Agriculture Biology from Seoul National University, Korea, followed by his Master of Science in Applied Entomology from Seoul National University, and earned his PhD in Entomology from Oregon State University, USA. His research interests include honeybee biology, pollinator plants interaction, insect biodiversity, climate change, ecology risk assessment, and sustainable pest management. Ladies and gentlemen, please join me in welcoming Professor Dr. Chu Lei-jung. Okay.
Good morning. Sawadee Krap. My name is Charlie Jung from Gyeongguk National University in Andong, South Korea. And I really appreciate the good organization from the organizing committee and also warm welcome from the President Sarichari Nambri in Yalla Ratchapat University and also Assistant Secretary of this province and Deputy of this city. And my title is insect because I'm an entomologist who study insect, so that I will talk on the insect as the vital resource for the green bio industry. So many people think insect as mosquito, fly, cockroach, or even agricultural forest pest, but there are many more insects serving as ecosystem providers. So we say good insect, beneficial insect, and also this will become a future resource for our green bio industry innovation. So my talk is the link from this ecological value as well as productive value and innovation value of insect, so that insect can be a good source of our future income generation, our future economic innovation. So I had checked through my publication and found that my publication all cover into 4 study area. Number 1 is honeybee health and apiculture. Number 2 is the pollination ecology and climate change. Number 3 is insect bioresource for food, feed, and biomaterial. And number 4 is insect and mite ecology, biology, taxonomy as a basic study. So I will describe and talk each part shortly. Number 1 is honeybee health, bee health. So everybody know honeybee, fang. So if there's no bee, no pollination, no apicultural product, no apiculture related product, so that taking care of animal health is very, very important. As you know that actually this green bio industry starts with the resilient biodiversity background, so that we have to protect each organism as well as biodiversity. So there are many risks associated with the honeybee industry. That is number 1, parasitic mite, pesticide, antibiotics, food, pathogen, climate stress. There are many, many risks, but this risk we have to carefully diagnose and intervene by treatment or by development, as well as its output is sweet honey, smart bee, healthy bee. So among these, I will exemplify one case of our study is food, because what we eat is what we are. So I have grown with rice-based food. So rice is my life. So honeybee also take honey and pollen as a food, but also they have many different diets, so that we have checked if honeybee eat honey, if honeybee eat sugar, if honeybee eat other carbohydrate, their life longevity change, big change. If you see, can I see? So if honeybee take only sugar, they can live only 10 days. But if they take sugar and pollen, they can live 2 months. Big difference. At this time, their gut microbiome, because this gut and brain and health are all associated. So there are big change of gut microbiome as well as physiology, genetics, and protein expression, as well as metabolomics. So another example is from our old history. So that from our old history, that in Joseon Dynasty, that is 500 years ago, there is a book written that if honeybee is bad, if honeybee is sick, then you can boil a chicken and then put them into the hive, then the honeybee will become healthy. Oh my God. This is a very new story. And I had discussed with my colleague, with Dr. Sampat, Dr. Not, Dr. Bam, and then we began the study of honeybee nutrition from the bee pollen, bee bread, pollen patty, and plant extracted protein, animal extracted protein, and showing significant innovative scientific work. From this work, we produce almost close to 10 research papers in this 4 or 5 years. Oh, next example is pollination. You know what pollination is? Honeybee move pollen from one plant to another, one plant to another. This is the way of pollination. So in this pollination is very sensitive system. In this sensitive system, you have to study on plant, animal, honeybee phenology, crop overlapping, and network stability, as well as you can utilize satellite image or airplane image, drone image for the nature positive solution for this pollination. There is an example. In Thailand, you have lychee, longan, mango, and rambutan, durian. All these are pollination dependent. This means without honeybee, without bat, without pollinating insect, you cannot produce any of these fruits in Thailand. So you cannot eat those. No mango without bees. So this is the pollination dependency. So that actually biodiversity is a vital agricultural or productive input for the better output. So if you make a good product from the pollination, then you can make a value chain, green bio value, certified product as a GAP or as a organic, so that you can make a better money from this. Next, I have some example. Sponge agriculture. This means this is what we are currently working on. So we want to create agricultural landscape with green cover, not with plastic cover, not with others. So we want to cover the agricultural land by green vegetation. So with this, you can conserve water holding capacity, you can buffer the temperature profile, you can increase the biodiversity in the agricultural system. This will provide better ecosystem. So this is an example. This is in Andong area. We create this flower strip as a pollinator habitat. So if you make this habitat, then this habitat will increase pollinator activity, and this increased pollinator activity resulted in better production of fruit. So actually, fruit quality is high, fruit production is high in diverse ecosystem. So third pillar. The third is on the insect as food and feed and biomaterial. So now there are many insect rearing industry. They can rear grasshopper, they collect bamboo moss larvae, and they also collect ant weevil larvae, and they produce many diverse insects. So because this insect has very high protein, good quality nutrition, and a high food conversion efficiency. This means they eat, and most of the eat, they become a body mass. So that, and at the same time, rearing insect, producing insect require less land, small space, less water. They don't use much energy, less greenhouse gas emission. This is carbon-friendly agriculture. Not only carbon-friendly agriculture, that insects also produce some different enzymes, different oil, different chemicals. This can become a good source of another industry innovation. One example is here. I put that, you know what this is? That insect, that's palm weevil, red palm weevil larvae. And red palm weevil larvae consume red palm biomaterial, and they produce oils, but that is not the oil. The next, so there are plastic degradation capacity. So there is a wax moth which consumes wax of the beehive, and this wax moth has been known to produce enzyme which can degrade the polyethylene. So that this is plastic. This is plastic, and you give this plastic to this insect. Then later, this insect will degrade this plastic. That is very important perspective. And then our team from Payao, from Chiang Mai, and from India, and from our team discovered that this lead palm weevil also could have some capacity to plastic degradation, plastic oxidation capacity. So that later on, if we study more, then we can use this insect for plastic biodegradation. Wonderful, isn't it? And more important is if you use insect, you can make a circular bioeconomic system. The example is, as I said, the red palm weevil and black soldier fly, and even there is a lino beetle production. Even in the lino beetle, in Thailand, I know there is a lino beetle fighting competition. So this is a big income generation source as well as leisure, but also during this lino beetle production, you use waste material, convert into biofertilizer. I will exemplify one micro livestock as a black soldier fly. This is the black soldier fly, and now its black soldier fly production is becoming more systemized. So like a cattle growing or pig, like general livestock farming, there are many places practicing black soldier fly farming. This black soldier fly eat food waste, livestock manure, and the agricultural residue, food processing byproduct. They eat and they process into insect biomass. And this insect biomass resulted in insect protein, insect oil, and insect material, chitin, and others. These are processed into animal feed in aquaculture, animal feed in poultry, animal feed in the pet industry, so that there are many evidence showing that insect fed or black soldier fly fed chicken has a very good nutritional profile and having higher price. So that this Benton chicken. You have a Benton chicken, and this Benton chicken can also consume insect as a partial diet supplement and make another additional value. Then lastly, this is on the basic science. So even applied science, bioindustry is very important, but you really have to keep focus on the basic science. Without understanding of the science, without understanding of the individual organism biology and science, sometimes bioindustry can be a guesswork. Guesswork means, oh, it can be like that, but there should be a evidence-based. So evidence-based. So for example, in 2006, I discovered one mite. That is one mite named Neoceus californicus. And I have known that this mite is a very good biocontrol natural enemy. And we did not, in Korea, we did not have that one before, but I found that. And I registered that as a biocontrol agent, and we had about 10 years research on this, and we make about 20 million natural enemy industry with this insect, with this mite. So that knowing insect, studying insect, or knowing basic biology and taxonomy is then much important. Another is on the ecological side. So ecology usually deal with the density and distribution, so that sometimes we want to know when something happened. So normally Yalla is the southern province, and so compared to the Phaya or Chiang Mai, the Yalla has a season quite earlier than northern province. But how many days? When? So this kind of information you can get from this phenology modeling. So based on phenology model, that this flower can bloom in the southern part earlier than northern part, so that you can distinguish this as well as distribution. So some insects distribute their high and their low, like this. Also, this is the climate change area. So now everybody talk on climate change. This year in Korea, record high heat wave. So like this case, many ecological things change. Nature change. How much change? We don't know. But we can estimate, we can quantify, we can predict those change from this ecological modeling. So that, for example, as temperature increase, then phenology timing decrease. So with this relationship, you can predict your future as well. And also, not only single individual, but there is many network change, overlapping change, global change. This change, we cannot study, we cannot sample everywhere. So that for this, we can use global data, we can use satellite image, we can use another one, so that using this information, you can make a predictive model for the change as well. So that I have to come very close to conclusion that actually research is important. But industry is also important, because without research, industry cannot survive. But without industry, research is nothing. So there has to be a good platform, good bridge. So this kind of knowledge bridge is very important. So I provide 3 modules of this green bio industry, which I am involved in my university. Number 1 is B, product and certification. This is number 2, pollination as a service. Number 3, insect biomass or biomaterial as a material science. So in number 1, my university, GKNU, so I am having the program of honey assurance program. So we collect and we test and we give them certification. This is standard honey. This is real honey. This is no leisured safe honey. This is DNA certified honey. So that this is certified so that actually industry can make more value. Next, in the pollinator network, so insect pollinator move. So sometimes this pollinator network, difficult to study because we have to go and we have to find the insect, we have to find the butterfly. So that we are using advanced technology called environmental DNA. So there is plant and we collect some evidence and then come back to the lab and sequence, find the DNA. Oh, then we can say there are butterfly visited. So using this kind of information, we can have better network understanding. The third is the insect as green biomaterial for sustainable future. So one example is we are extracting exosome from honey and from pollen. And this has revealed that has a very good cosmetic capacity. So when we make cosmetic materials, not only using honey, not only using bee pollen or bee venom, we extract some important material. Only those material can be used for the cosmetics. So as well, we use insect as protein producers. You know, once in the diabetics, and so that diabetes people use insulin. So some people without insulin, they collect insulin from animal. So they use animal, for example, pig, to produce insulin for us. But now we can use Bombus lava or Bombix lava to produce them. So we use insect as a biosimulators. And also silkworm, silk. You know the silk, so insect silk, animal silk can be used as better performing your biomaterials and so on. So I have to finish. So that insect is not a single industry. They can provide many diverse application performance. So insect biomass, landscape, health bees are all interrelated. By the way, I have to close this session by saying appreciation. Thanks to President for last night. Very warm welcome. And also this event is based from our MOU between Gyeongguk National University and Yalla Ratchapat University last year with Vice President Chiat, as well as at that time we made one green bio symposium with many Yalla team, with our team. And by the way, thank you very much, and kakun.
Thank you very much, Professor Dr. Chu Lei-chung, for your insightful and inspiring keynote presentation. Ladies and gentlemen, we will now proceed to second keynote speech entitled Sustainable Biomass-Derived Cellulose and carbon materials from chemistry to applications. It is a great honor to welcome Professor Dr. Rodolfo Cruz Silva from the Center for Research in Applied Chemistry, Mexico, and Shinshu University, Japan. Professor Cruz Silva is a research professor affiliated with the Center for Research in Applied Chemistry, Mexico, and Shinshu University, Japan. He specializes in carbon nanomaterial, polymers, polymer nanocomposites, and advanced membrane materials. Professor Cruz Silva received his Bachelor of Science in Chemical Engineering from the State University of Coahuila, Saltillo, Mexico, and earned his PhD in Polymer Science from Center for Research in Applied Chemistry from Saltillo, Mexico. His research focuses on designing and developing advanced materials from laboratory research to practical application, including the designs of prototyping of new materials, performance optimization, and technology development. Ladies and gentlemen, please join me in welcoming Professor Dr. Rodolfo Cruz Silva.
Good morning, everyone. I'm very excited to be here and share some of the research that I am doing in Japan, but also in Mexico. Yes, yes, yes. Well, as I was introduced, I have a double affiliation. I work in the aqua regeneration center in Shinshu University, but I am also work in the Center for Applied Chemistry in Mexico. One moment, please. Thank you. Okay, first, let me tell you where is the Shinshu University. Shinshu University is located in the central part of Japan. It is a place that is very famous for the Winter Sports Olympics of 1998. And that is our research building. It was built in 2014, and we work in several fields, not only in water-related issues. This is a picture of the city from the windows, actually from the laboratory in the 6th floor. It's a very beautiful place. You see the snow on the mountains. And Nagano has a lot of very high quality water resources because it receives a lot of snow every year. So in spring, the snow melts and very pure water comes from the mountains. This is a very famous national park, Kakamikoshi. You can see the water is completely transparent. The research center in Shinshu University works also in topics such as green hydrogen production, which is a very important resource in this 21st century, and also works in many technologies related to low energy consumption materials. Our group, that is led by Professor Endo, works on the development of high-performance reverse osmosis membranes. We have been working with this topic since 2014 in the previous research center called the AWIS Research Center. And since 2022, it is now called the Aqua Regeneration Center of Shinshu University. It is very important to notice that one of the goals is to develop products to treat water in places where pure water is not available. And that brings me to my place in Mexico, because Mexico, the northern part, is a very arid zone, and the water resources are limited. This is the place where I am working full-time in Mexico. It is the Center for Research in Applied Chemistry. We work mainly on plastics, and part of our job is to train people to work with extrusion, injection, and plastic processing for the companies. We have a hub of automotive companies like General Motors, Kia, and so. So there is a lot of work related with plastics for the automotive companies, but also related with work of plastics for water treatment, because the water is a resource that is not available as in Japan. You can see the landscape is a little bit arid on the back. So another topic that I'm working is the development of carbon from biomass. I've been working with carbon since 2008 when I moved to Northwestern University for a couple of years to work on graphene and this kind of materials. And then I moved to Japan to work in the research center for exotic nanocarbons. Carbons are very broad type of materials. Every source of material to make carbon results in a different carbon. If you get carbon from wood, if you get carbon from oil pitch, if you get mineral carbon, all of these carbons are actually different on the molecular scales. And this is why there is a lot of research on carbon. So the idea now is to prepare carbon from agricultural residue, because it's a resource that is available in many developing countries, like Mexico. So one of the advantages is that we can use the waste to obtain a product, and it is very important from the circular point of view of the economy. And also, these carbons are naturally porous, which is a feature that we need in order to get carbons for absorption for water treatment, because porous carbon allows the water to diffuse inside the material, and then the contaminants, the pollutants, can be absorbed on the carbon. So biomass-derived carbon is perfect source for this kind of materials. And also, because it is a greener alternative, instead of using oil pitch or mineral carbon to make activated carbon, we can use carbon from agricultural residues. And this is one way to take advantage of the residues. And this scheme provides circularity to the economy. So we can go from the product to waste and vice versa. One of the work that we did a long time ago was to use a residue called carbon rice husk, which is available in Japan in large quantities. So rice husk, actually, it is used for many other applications, like in the food chemistry field. But also, we can make very good quality carbon if we mill this residue and we heat in absence of oxygen. We can obtain carbon, and we can obtain some briquettes. And when we see the microscope image of this carbon, you can see that it's like a sponge on the atomic level, and it has a lot of pores where the pollutants can be absorbed. So it is a very high quality carbon for water treatment. We use very high resolution transmission electron microscopy to analyze the structure, and we found that if we heat this carbon to very high temperature, we can obtain actually graphene type carbon, which at that time, in around 2012, it was very, very attractive for research because it was just announced the Nobel Prize 2 years before. So we found a very natural method to obtain carbon. And this carbon has high electrical conductivity, which brings to some applications in the energy field. You can see in this image that were obtained by Professor Hayashi from Chinshu University, the atomic scale and the network of hexagons and pentagons and the defects of the material. So, as I mentioned, because this carbon was prepared at high temperature, the conductivity is very high. So we can use this carbon to make electrochemical supercapacitors. And these materials are very attractive especially now for the automotive companies because of the hybrid materials, the hybrid cars. Not only batteries are important, we also need capacitors these capacitors are able to deliver a very high power density of electricity. So cars like the Prius, they rely on capacitors to storage energy during the braking and release this energy once we accelerate. So we carried out electrochemical characterization, and we found that the carbon obtained from rice husk is actually a very good carbon to make electrochemical capacitors. And this is one example of one product that we can obtain from agricultural residue. In Mexico, we use groundwater, and the problem with groundwater is that sometimes it is contaminated with heavy metals. In the northern part of Mexico, the water sometimes might contain levels of some metals like lead or arsenic that are not acceptable. So we need to develop carbons that can absorb particularly these materials. So we are using hybrid materials made with carbon and polymers because the polymers can improve the absorption properties of the carbon. Carbon, it's a very good material for water treatment for organic pollutants, but in the case of heavy metals, it's not the best one. But if we add a polymer, we can reach very high levels of metal removal. So we are using a very interesting polymer called polydopamine that is actually inspired by nature. This polymer was found around 2008 in Northwestern University by a group working on biomedical research. So they were trying to guess why some clams were able to attach to the rocks even in aqueous media. So it is a kind of glue that is very strong. So they analyzed the protein of this clam, and they found that it had a lot of amino acid called lysine and dehydroxyphenylalanine. But these materials are expensive, so they instead use a monomer called dopamine, which combines these two materials and can result in a polymer that has a very strong adhesion and very interesting properties for removal of contaminants such as heavy metals. Another topic that we are working is how to use invasive species to make polymer composites. One of the rules that we should take into account when we develop materials from agricultural waste is that we should not use endangered species. So in Mexico, for instance, there is a grass that was introduced from South America because this grass is very resistant to drought. So people thought, okay, if Mexico has water problems, maybe this grass is going to be good. The problem is that the cattle, they don't like eating this grass. And when they eat this grass, actually, even if they digest the grass, they don't gain weight. So this grass is very strong and spread on the south part of the country. And now the government is trying to find one reason so people can remove this grass. So we are working with making composites like wood type materials using this grass and another polymer of natural origin called polylactic acid. And of course we have to add some additives like glycerol, which is a very low toxicity plasticizer, and we can mix this material. So how we prepare this kind of materials? Well, we take the grass, we dry the grass, we mill the grass, and we then separate the grass by sizes, and we obtain a powder of the dry grass. And then we apply a very typical method to extract cellulose that actually I learned in Japan while working with bamboo. But it also works for most cellulose sources like grass. So we treat first with a very alkaline solution. This is a very low-cost material, the sodium hydroxide. We wash the grass, and at this point, this solution can remove the lignin. Then we apply an acid wash, and we remove the hemicellulose that is transformed into sugars that can be removed from the plants. And even we can adjust the level of acid if we want to obtain long cellulose fibers or very small cellulose nanocrystals. The process takes a few hours, and it's carried out at relatively low temperature and under ambient pressure. And finally, we wash the cellulose remaining with sodium hypochlorite, which is basically bleach. And we can obtain something very similar to cotton from the grass, that then we can mix this material with polymers to make wood-type composites, because these fibers can improve the mechanical properties of the polylactic acid. So we mix this. If we see the image, we can see on the left, the microscopic image of the original grass, and then after we wash, we can see that we only have cellulose fibers, and this cotton-like material can be mixed with the plastic using a plastic processing equipment, and then we can mold it, and we obtain that kind of wood-type material, very strong, resistant to cracking, and we can measure the mechanical properties, and we found that it's actually very good reinforcing material for plastic composites. What is the advantage of this material? This material can turn into soil in less than 90 days. So it comes from natural plastics and a plant that is not supposed to be there in the first place. So we provide an incentive for people to collect this grass and help with the eradication of this plant. At the same time, in Japan, we were working with the cellulose obtained from bamboo, which is a very high quality cellulose, probably one of the strongest cellulose. Everyone knows the bamboo has a very, very strong mechanical properties. So one method that was developed about 20 years ago was to use a chemical compound called tempo to oxidize this cellulose, so we can render this cellulose water dispersible, and we can end up with a kind of a solution or dispersion, colloidal dispersion of cellulose, so we can use this material for many applications, even food chemistry. It has been used, for instance, to make ice cream as a stabilizer, but we use it also to make membranes. This is the resulting material is very small. It's dispersible in water, and it's very small fibers of cellulose that have oxidized surface, like it is shown on the left. The right has an AFM image of these very small cellulose fibers or nanofibers. So we developed some special membranes, and I will explain why they are very useful in Mexico. This is the map of Mexico. If you see the south and the places that are closer to the sea, they have better weather for cellulose production, and they have more water, and they have rivers. But in the center, which is the place where I'm working, it's very dry, kind of desertic, very similar to Arizona weather. So we don't have rivers, we have groundwater. This is a picture of the city where I live. You can see the mountains on the back. There are basically not so many trees. And on the left, this is the satellite image. So how we get water in this city that is close to 1 million people? Well, it rains on the mountains, and then this water infiltrates into the soil. And then in the left, you can see all the wells that we have to make to get water for the city. But the problem is that when this water travels underground, it dissolves a lot of salts, calcium and magnesium salts. And these are very bad, because when we get the water, it creates a lot of problems. The first one is the scale formation. It looks dirty, but it's not dirt, it's mineral. You get mineral on the faucet, you get mineral on the shower. This water is not so good quality water. If you have a boiler, it builds up minerals, and you have to clean the boiler, and it adds money to every process that when you need to use water. And it also reduces the life of all these appliances. So, and one of the main problems is when it mixes with the soap, it is not a good detergent anymore. It becomes like a wax. So we have to use commercial products like this one. Otherwise, it's even impossible to wash the water, the clothes, because you cannot, you don't have the detergency of the pure water because of the salt. You can see it on the pictures the difference. On the left, you have soft water. This is very good soap. The same soap on the right, which is made with the water we have available, it becomes this waxy material that is very annoying and not good. And also affects cooking, because calcium and magnesium can cross-link proteins. So if you have, for instance, beans, soybeans or just beans, that have a very high protein content, if you cook this in this kind of water, it becomes very hard because it's cross-linked. And if you boil, for instance, spinach, it also affects the colors of the chlorophyll. So if you wash with this water, also the hair becomes more stiff, and sometimes you get some salt on the skin. So we have to treat this water. So we use membranes because membranes are a very good alternative, low energy method to remove the salts. This is one video to make a polysulfone support membrane by a method called phase inversion. Basically, we dissolve the polymer, and then we spread this polymer. This is a research level membrane. We spread the polymer on the glass, and then we spread the solution, and then we can precipitate this membrane. In the industry, actually, this process is made in a continuous way. But for research, we do it this way. So we put it in a water bath, and then we have a membrane, research-grade membrane. In the industry, actually, this is made in a continuous method. But this is how we make the membranes. We use the support membranes. We use this kind of test to measure the permeation and the quality of the permeated water. We have a controller. We have some balances to measure the amount of water that we can filtrate. We have some pumps, some pressure controls. It's a relatively simple setup. And I want to show this paper because actually it was done in collaboration with Professor Winada that works in Bangkok. And we develop membranes called point-of-view membranes. These membranes are used at home to purify water from the faucet. So these membranes were made in the similar way, but adding cellulose. So cellulose is very hydrophilic now. So it improves the permeation of the membranes, it modifies the morphology, and it improves many properties. Like we prepare these modules that are very similar to the ones that you can get online to filtrate water at home. And if you see, the blue line is the permeation of our membrane with cellulose, and it's very high compared to the commercial membrane shown with yellow. We compare with several commercial membranes, and we notice that the membranes have actually about the same level of rejection of calcium, but very high permeation. So this is one reason why adding cellulose to these membranes can improve the performance. We also use cellulose to check the chlorine resistance of the membranes, because one of the problems of membranes is that they degrade with the chlorine that is added to make the water drinkable. So that's the main reason of degradation. And in this test, we showed that the Cellulose membranes, that are the blue lines, have longer life, higher permeation than control membranes. And this picture actually shows a comparison on the both sides. On the left side, we have a polyamide membrane. On the right side, we have a polyamide with cellulose membrane. After we treat with chlorine, you can see that the reaction, which is shown by the yellow color, is lower on the membrane with cellulose. So cellulose is a very good protection agent for membranes against chlorine. And we carried out a lot of molecular dynamic simulation. Okay, the videos are having some problem. But anyway, I will comment some of the perspective of this work. So the first one is that we should valorize the waste. In this new model of thinking, waste is not anymore something that we can eliminate. It's something that we have to reuse and get some value from it. So everything, if you have a restaurant and you have food residue, you can use the food residue. Professor Xiongdio gave very good example of how can we use waste residue. This is another method. We can use residue to make carbon. We can use the residue to make cellulose. And we should always try to avoid using food or crops that are used for food. Like, we should not use the rice, but we can use the rice husk. Because, of course, food scarcity is also another problem. So we should focus on the residue of the industry. And we should develop a low energy method because climate change is a big problem. We have to reduce the CO2 emission. So we focus, if we want to make carbon, we have to find methods to make carbon at lower temperature. And also, it's very important to develop new membranes for special needs. There are very different type of pollutants now. The water in Bangkok, the water in Tokyo, the water in Mexico, all of them are different. So we have to develop membranes tailored for each type of water in order to maximize the life and to improve the rejection of the compounds that we want to treat. And finally, I want to also comment, like Professor said before, it is very important to develop a business model. So I just came 2 weeks ago from the carbon conference in the United States. There are many companies making carbons, different type of carbons. There are many companies making carbon now from agricultural waste. If you go to places like Alibaba or even Amazon and you search for carbon material, you will find carbon from many sources. So this is something that we should think about. How can we make a carbon company using local resources and make some product that is useful? And finally, well, I want to thank the organizers. And this is my email. I will be very happy to discuss. And if you have any questions, if you want to visit Mexico or Japan, I also will be very happy to welcome you. So thank you very much.
Thank you very much, Professor Dr. Rodolfo Cruz Silva, for your excellent and insightful presentation. Ladies and gentlemen, we'll now proceed to the third keynote speech entitled Mud Crab Research and Translation, a case study of synergizing transdisciplinary approaches in science technology for local economic development. It is our great honor to introduce Associate Professor Dr. Sukonrat Sukri Hayisame from Prince of Songkhla University, Parini campus. Associate Professor Dr. Sukonrat Sukri Hayisame is a distinguished scholar and researcher specializing in coastal aquaculture, fisheries technology, aquatic ecology. Growing up in a traditional fishing community in southern Thailand, his research has focused on ecology and biology of aquatic fauna, particularly in fish, crab, shrimps, and mollusks. He received his Bachelor's of Science in Fisheries Technology from Prince of Songkhla University and his Master of Science from University Pertanian, Malaysia, and PhD in biological science from National University of Singapore. His research has particularly addressed the ecological and management challenges of Pattani Bay, including impact of coastal infrastructure such as wave barriers, artificial reefs, and green mussel reef on aquatic fauna. Ladies and gentlemen, please join me in welcoming Associate Professor Dr. Sukonrat Sukri Hayisame.
Very good morning, Mr. President, Vice Presidents, colleagues, keynote speakers, plenary speakers, presenters, students, ladies and gentlemen, peace be upon you. Very excited to be here in the stage. This is one of the, actually the first time ever that I've been here as the speaker. Rajpath University, which is actually we are very close. Thanks for introduction, Mr. MC. Okay, slide is here. For there are many students here, and I hope that you will learn something from my talk. This talk is about the mud crab research and translation. If we say in Thai, with translation means แปลใช่ไหมการแปล The meaning is that now we are talking about research and translation. Actually, translation is not new in science and technology, as our first speaker already mentioned about. Translation is very important. We need industry, and industry need research. We have to work together. So in the past, research work and publish papers. Research work and publish paper, and industry said, what is research for? But this work of my group, we try to translate research from the lab, collaboration between the different disciplines to build something, produce something that meaningful to the society, to industry, yet can also create funding or a profit to the university. So my topic today is mud crab research translation, a case study of synergizing transdisciplinary approaches in science and technology for local economic development. Slide, please. ไม่ไป okay. So actually the concept of my talk, there are three main focus. The first one is we bridges academic research to the real world application. Let me summarize a bit in Thai. ทำยังไงให้งานวิจัยจากห้อง lab เนี่ย ไปตอบสนองต่อความต้องการจริงๆของคนใช้งานจริงๆอันนี้คือหัวใจสำคัญเลย The second is we foster holistic problem solving nobody can solve the problem alone no single person can solve the big problem alone so this is the point I try to mention in my research my talk and this work we bring people together we do research that relevant to the real world but the priority of the real world is the regional is our region เราทำวิจัย have to translate professor โอเคเราทำวิจัยที่มันจะตอบสนองใน lab แล้วก็ตอบสนองในโลกแห่งความเป็นจริง1 2ก็คือเราต้องรวมคนหลายๆคนเพื่อมาแก้ปัญหาหรือว่าไปสร้างอะไรบางอย่างขึ้นมาและไอ้ที่เราสร้างอะไรบางอย่างเนี่ยเป้าหมายเราต้องการพัฒนาในพื้นที่ให้ได้อันนี้คือโจทย์สิ่งที่จะบอกเล่ากับพวกเราฟัง so after this I will go directly by English so normally this is for I think that we have many academic staff here too apart from student academic staff the president is here already force you do research do teaching you have less number of students your program will be closed down soon bring money to the university and many more go outreach go to the village help people that is stressful this is the stressful of the university's staff now the academic staff now but I think that we actually can overcome this we can do all this target we can combine together within one work one research work you can answer teaching student you can answer research grant you can answer paper you can answer about outreaching to the community you can answer generate income to the university and of course you can bring the global network or local network or regional network and many more so my team I can say that my team this is only not myself as the what to say as the speaker of my team I was asked to be speaker of the team so try to publicize what we are doing we are working on 2 crabs now we are working on 2 crabs first is mud crab second is blue swimming crab mud crab is ปูดำ blue swimming crab is ปูม้า kalau bahasa Melayu panggil gapo tahu tak mud crab panggil apa ketek apa they don't know kepiting oh you're from Indonesia you're from Indonesia all right great which part of Indonesia dari mana dari Medan I'm going to Medan next month yes to the University Negeri Medan to present my talk and so we work on these 2 species of crab we just try to focus on these 2 species of crab why and today I talk about mud crab why mud crabs first mud crab is the agriculture product that been culture in Thailand for more than 4 decades second at Prince of Songkhla University where I'm working now we established the first course ever on mud crab for Thailand that is about 40 years ago in 1988 that is very long less than 14 years and the mud crab become a target animal due to high demand potential for aquaculture possible technology and the running down of the shrimp industry this happened in Indonesia this happened in Malaysia I heard that UNICEF also here so that's why it's mud crab and government policy so 10 years ago my team we start to think about mud crab but luckily we start with the policy research we work with SOCOWO National Research Council of Thailand or something like that so my responsible is think about the aquatic species If you want to develop aquatic species in Thailand, pick up few species. When we analyze, mud crab is one of the potential species. So we pick up mud crab as one. Apart, there are 5 more. I can't remember. I can't remember the number exactly. So we try to think about the supply chain, what we already have and what are missing in the supply chain of mud crab, especially science and technology that will promote the development of mud crab, what we are lacking. So we start from broodstock, we start from hatching, culture, what about the system until the marketing, the processing. Normally, as a lecturers, as academic in the university, or even as the researchers, when we think about one project, one research project, we normally think very narrow. For instance, impact of black soldier fly to growth of mud crab, for instance. That is we normally think about. This is normally our normal research question, which is good, which is correct. But this, to me, we cannot drive the industry holistically, but we can only solve that particular problem. So we start thinking about a little bit policy based. So when talk about mud crab, we look at the base. What is the benchmarking? What is the baseline of mud crab industry in Thailand? And what is the target of Thailand policy? And then what missing? So that missing we have to bring. And then we have to start from our lab. So then we start thinking about this. So we believe that, okay, it's too much work. No, we want to be a happy professor. We want to be a happy lecturer. So to be a happy lecturer, what's that? We have to integrate. We have to integrate all the KPIs set by the university. It must be in one work, not 4 work, but one work you can apply. You can answer all the university's KPI. So we start with education. So this project, education, yes. We produce a lot of master's students, PhD students, postdoctorate students, and even undergrad students. Research, definitely. We publish a lot of work. We produce a lot of innovation for mud crab industry. Social science, marketing, business, economic, administration, you must be there. Once you create something, who will sell your product? We scientists, we technologists, it's difficult to do that. And network, you create a lot of network after that. So for us, this we call the value to society. Our aim is value to society. In education, we produce students. We have produced papers. In our mud crab group, I think that more than 15 papers we publish in high impact journal, even with small group. And we support supply chain. From our project, every year we support about 100 million baht to the supply chain. It means that without our work, our production, this 100 million baht will not exist in Thailand. Our small team. And we generate income for the university about 1 million baht a year. That is the net income to the university, not from the research project. And of course, we have network, collaboration, and we change policy a lot. So what we are doing, we synergize. We call synergizing approaches. We work on the left hand side is the basic science, very basic science. If you want to publish, you go for basic science. If you want to do technology, you need a strong basic science. You have to develop basic science. If you go to technology, it's difficult to publish. But technology can translate to the society. So we combine this together. So we bring in science, we bring in technology, innovation, business management, supply chain, etc., as I mentioned. So our team, you can see how fun my students and my team, we work with crabber, with a person who catch crab. Especially in Asia, we work in Thailand, Malaysia, Indonesia, Bangladesh, and Myanmar. My students, they travel, some students from those countries. We work together. just to gain insight, the knowledge. We work on basic science because we believe that basic science is essential. Without basic science, you cannot go far, you cannot fly high. So we work on basic science. We try to discover many questions left in basic science. I think those who are in mud crab, I'm not sure any of you in mud crab world. So this kind of photos of this, I think they distribute a lot in the mud crab society, but it's from us here in Thailand, in southern Thailand. So our research, we create supply chain and value chain. We're not only doing research in the lab. You can see we start from the broodstock, and we build our hatchery. We build our own hatchery in the university, and then we start producing the seed, the baby crab, and we sell to the farmers. We educate farmers. And then we also work with the restaurant. This is how our supply chain. We do research on all supply chain, because our aim is to leverage, to increase the capacity of mud crab industry. So we we develop the facility infrastructure on campus. Everything is inside the university. Now I can claim that as a travelers, I can claim that we can say that our center for mud crab is the best research center in the world with fully equipped facility on campus. Everything is in one hand. So that is something about us. We are very close to the sea. And what is our strength now? We are the only broodstock producer for Thailand, replacing the broodstock exporting from Vietnam, our neighboring country. We are the only broodstock producer in Thailand now. So it means that if you want to work on mud crab aquaculture, you have to come to us, because we have the broodstock. Broodstock knowledge, we developed about 5 years for broodstock development. And this broodstock, it was a botanic for Thailand. When I first jumped, I'm ecologist actually, and then turned to aquaculture about 10 years back. When we jump into this mud crab world, the botanic is broodstock for Thailand, not for Vietnam, not for China. So it's easy, we learn from Vietnam. We learned from China. It was in China last month. And then we imported from neighboring countries. And then what happened now? We benchmarking them. We already complete that. And our technique is ethical. Our technique is now published in FAO. It's gonna be FAO manual. It's already in FAO for broodstock. Just 10 years of working. So this is what achievement that our team are very proud of it. And then now we are hub of broodstock. You can see we send to everywhere in Thailand. And our technique is no eye stalk ablation. Normally they cut the eyes, like many crustaceans, they cut the eye to induce spawning. But our technique, no eye stalk ablation. That's why FAO prefer our technique. It's more ethical to the animal. It's more healthy to animal. So that is about science. Now our research center turned to social integrated enterprise. This is a new word again for Thailand. Social integrated enterprise. I'm wearing this shirt now, this jacket. Social integrated enterprise, or SIE. You look on this screen, it's about business. No science, no technology. It's about business. We are selling. Now we are selling our product. What product? We sell broodstock. We sell zoo ear state. We sell megalopastate. We sell crablet. We pay market size crab. We sell juvenile crab. And we sell training course. 2 months ago, I got a colleague from India. Our speaker is here. He's flying from India, stay here for 1 month from a company, training here for 1 month, and then we charge them, of course. And then this is one of the things we do. This is our product, that what we sell, and then what is the impact. From our sale, what is the impact to the society, to the industry? And what's next? We still want to go further. What's next? Last week, we have a president of Betacro, Mr. Wanat. He's the owner of Betacro. Came to see us and just tell me, Sukri, you have to turn your SIE to become company limited. With university hold the share not more than 50%. Less than 50%. I said, why? Normally university want more than 50% to show the ownership. But he said that no. If you allow university to hold more than 50%, it's very difficult for you to work. It's no different from what you are doing now. Because everything, you have many boards to do that. So now I have to negotiate with the university. If we want to create something more. This is not new for South Korea. This is not new for Taiwan, but it's new for Thailand. It's strange, it's new for Thailand. It's not new for China. South Korea been doing this for decades. Not decades, even decades. Taiwan definitely, but not in Thailand, right? And so we are trying to do this, and then we promote mud crab also. This is the outreach we promote, and we create job. We work with โฆษณาให้ร้านบ้านเลนะในฐานะที่ไปมีส่วนกับเขาบ้างท่านอธิการได้นะโฆษณาร้าน This is Banle Seafood now. It's become one of the best restaurant. You should go, Prof. There. It's only 30 minutes. Good seafood and cheap. Ask President to bring there. Yeah, I enjoy some actually. This is start from mud crab work, and then now we create quite good restaurant over there. And then what happened to Thailand? The mud crab industry. You can see the growing up of mud crab from 227 million baht a year, very small. Now 1.2 billion. And our target is 5,000, so we have to work much harder. And this is how we work. We have network, we have regional linkages. Many countries we are working with. Not only we have Hong Kong, not Taiwan yet, China, Malaysia, Indonesia definitely, Bangladesh, Myanmar. This is all our partners. We work together. And next year we are having, we will organize, we bring all the experts, the best mud crab scientists, technologists, traders come to Pattani to think something about mud crab. And then this is how we work. And for policy maker, this kind of idea, this kind of model, they are very, I think that they're very supportive. So we have our former Prime Minister carrying mud crab, our mud crab. Just visited us, and some few deputies Prime Minister already there. And we also create a lot of students. This is my master and PhD student. You can see from different countries. Ramai dari Indonesia, banyak dari Indonesia. Sekarang saya ada double degree program from Airlangga, 3 orang. Sini 2 orang di sana. Airlangga UNAIR, Universitas Airlangga. And we publish a lot of some papers and collaboration with many universities, and come to the conclusion, what the message I try to deliver today is mud crab aquaculture is evolving. This is for scientists, for industry, offering new hope. The key factors for success is sustainable supply chain. So we have to create supply chain and sustainable supply and connect supply chain. Strategic research and development, strong support from government, farmers, and entrepreneurs. To develop supply chain, we need to integrate science, technology, and innovation as the theme of this conference. And a new model for social integrated enterprise, feature 2 to bridge research and translation. Pray for us, because we are fighting for the new model for Thailand as well, so we can work together. So this is my team, very big team. Thank you so much for your attention. Thank you.
Ladies and gentlemen, thank you very much. Thank you very much, Associate Professor Dr. Sukunrat Sukrihayasameh, for your valuable and insightful presentation. We really enjoy listening to your presentation, honestly. Ladies and gentlemen, we will now proceed to our final keynote presentation entitled Holistic Nutritional approaches to sustainable antibiotic free broiler production. It is our great pleasure to introduce Dr. Sutisak Bunyang from COP Asia Pacific. Ladies and gentlemen, Dr. Sutisak Bunyang is a nutritionist at COP Asia Pacific. He joined COP in 2020 and specializes in animal nutrition, quality assurance, feed processing, and research. He has more than 10 years of industry experience in practical feed formulation, nutrition, food safety, and solving nutritional challenges. He holds PhD from Tokyo University in Marine Science and Technology and has professional certificate in food safety and quality management. Ladies and gentlemen, please join me in welcoming Dr. Sutisak Bunyang.
Thank you very much for your introductions. Okay, good morning. Selamat pagi. Annyeonghaseyo. Oyo gozaimasu. Namaste. Ni hao. And also, I would like to say like a good morning. And also, I have like a 30 minutes before the lunch because I think that right now you feel like a hungry, right? So, I will go very quick for this one. And also, the one thing before starting my presentation, I would like to introduce my company first. My company is Genetics. This one like a genetic company and also belong to Tyson, the head company. This one is the biggest producer in the world, chicken producer in the world. And also this one, the topic, the title today that this one is belong to the food safety. It also belong to the consumer health as well. So how to reduce the antibiotic that we use in the broiler production and also the feed. This one is very important. So I will show you that how to implement the feed additive and everything, the feed formulation that can reduce the antibiotic in the chicken feed. So this one is the section, the content of my presentation. The first one, I will introduce you a little bit about the global chicken production. What is the mechanism of the antibiotic? What is the concern point of the antibiotic that we use in Asia and also in other countries as well? And also the last one, the last part, this one is very important. I am nutritionist, that's why I will propose you that if we want to withdraw the antibiotic, so we should design the feed formulation. We should implement some feed additive into the feed that can help the bird grow. Okay. This one, I show you about the data about global meat consumption and also the sharing as well. So you can see in this one that even like a low income country, the high income country, the poultry meat, this one is sharing the main protein source. So why the poultry meat is very important? Why the people love the chicken meat? Why you love the chicken meat? Why you love the chicken meat? Okay. The answer is here, universal, right? Because even like a Muslim, Buddhist, Christian, we can eat the chicken meat, right? Except vegetarian, they cannot eat anything, right? So, and also the next one that, this one, we thought that the chicken meat is the healthy meat because it contains low fat and also very high protein. How about a global chicken production? You know about that. The protein meat, this one is the main protein source, and also this one like a global chicken production. You can see that the first one is the US, produce a lot, and then followed by China. And also you can see that Thailand, our country, we are also in the top 10 chicken producer as well. But the one thing that in Thailand, we produce the chicken, but for not ourselves, we export to EU country, and also we also export to Japan as well. Japan is like our customer. EU is also our customer as well. And also the one thing is that China, Thailand, US, we eat the bird in the different size. For example, in the US, they love the big bird over than 3 kilograms. In Thailand, we love only 2.5, 2.2 kilograms. In Philippines, they love to eat the whole bird, 1.5, 1.6, 1.7 kilograms. That's why it have the different market in Asia. And also, this one, the main point of this one, why we use the antibiotic for the broiler. Normally for the antibiotic, we use this one to control the infection in the gastrointestinal tract of the bird. And also we use this one to the treatment, to the prevent the disease of the bird. We can use in the feed, we can use in the water, and also we can use in the oral way as well. And also, the antibiotic, why it's so popular for the chicken meat production? Because this one is the antibiotic growth promoter mechanism. When we use the antibiotic in the feed, it can suppress the pathogen, right? So when they suppress the pathogen, so it means that it can remodel for the microbiome. The second one is can enhance the nutrient digestibility. So it means that the bird can absorb more nutrient and also can grow better. The last one, the bird don't have the stress. They also don't use the energy to produce the immune. It means that they can use the energy for themselves, for the protein gain, for the body weight gain, and also for the FCR. That's why antibiotic is very popular. And also you can see in this one that when we conduct the trial, like in many trials, like 30 trials in Asia and also in other countries as well, we see that when we use the antibiotic growth promoter in the feed, it can reduce FCR around 5 point until like a 10 point FCR. So it means that it can increase the profit in the chicken industry. So, what is the concern point when we use like an antibiotic growth promoter? The first one, we know that when we use the antibiotic growth promoter, this one is can enhance the chicken growth. It also can make the issue on the gut health. I highlight on the gut health. The gut health is very important. And also, this one is also can impact on the immune system. So, why gut health is also related to the immune system? I think that you may know that the gut of the bird or like for the human, this one is produce 70% of the immune. That's why if we have the issue in the gut, we also have very sensitive for the disease infection. So that's why the gut health is very important. So what is the second one is it can make the bacterial resistant. So that's why this one is very important because it can make the mutation in the bacteria. The next one is can reduce in the chicken meat and also in the egg as well. This one, that's why when we take like a chicken meat, when we take like a egg, this one we also have like the resistance of the bacteria. The last one is very important. This one is for you, all of you. This one we talk about consumer health, food safety, and also environment. So that's why when we use something like the antibiotic, yes, we can improve the growth performance, but we should consider another thing as well, that how about the like a consumer health, how about like a environmental impact as well. So this one is the data. So this one, the data, this one it shows that when we increasing to use the antibiotic, we also increasing the percentage of the bacterial resistance. And also this one is not only in Asia, in other country as well. Not only in Thailand, not only in Bangladesh, not only in India, it's also in the US and also in the European country. So that's why we know that the antibiotic is really, it can make the issue to the broiler chicken production. That's why this one is already banned in some country. For example, in the EU, it started from Sweden in 1986, and also in Thailand, we already banned as well, like a 2006. But the one thing that we banned this one 20 years ago. But right now, we still observe the antibiotic residue in the chicken meat in Thailand. So that's why it maybe something happened because maybe like a wrong direction to use or something like a illegal to use it. So that's why in the officially we already banned this one. But in the reality, we also found the antibiotic residue in the chicken meat in Thailand. Not only in the chicken meat, the pork meat, egg, tilapia, and also like a shrimp. We also found like a 50% of the sample, at least we found like a one antibiotic right now. Okay, this one is very important part. How about to use the nutrition? Because I am the nutritionist, I want to approach you about the solution that can implement in the industry. So this one is the nutrition strategy that we can implement in the feed. The first one, we talk about organic acid. Organic acid, so it means that this one is can lower gut pH and also like a antimicrobial property. The second one, NSP enzyme. This one, NSP enzyme, is widely used in the chicken feed, not only in the chicken feed, in the pig feed as well. The next one, we talk about prebiotics, probiotic, symbiotic, and also I will explain you in the detail because this one, sometimes I also confuse about this one. The next one, we talk about the mineral. Normally, for the mineral, we also supplement in the feed as well. We talk about the iron, zinc, and also like a manganese. The minimum inclusion rate is around 100 ppm. We should supplement in the feed for the chicken growth, and also this one is also can enhance for the immune system. The next one, phytogenic compounds. So normally this one, I found a lot of product from India. Okay, not there. From India, because a lot of product from India about like a phytogenic compounds. The last one, mycotoxin. We talk about aflatoxin. We talk about silalinone. We talk about T2 toxin. This one is can make the issue on the gut integrity. So, have you seen this one before? The family of the biotics. Normally we know about prebiotics. We know about probiotics. And also prebiotic and probiotic. This one is have the commercial product in the industry. But the one thing that right now we have symbiotic. Symbiotic is the product that contain pro and prebiotics. And also another one we have symbiotic. Confused already, right? I also confused, don't worry about this one. I also confused. Symbiotic, this one is mean like the prebiotic plus the enzyme. This one is have the one product in the market. It have the one product in the market. And the last one, we talk about postbiotics. Postbiotic is the active substance from the fermentation process, right? From the probiotic, ferment the prebiotic, and also we can get like a postbiotic. This one is very important because this one can help the gut of the bird. The fiber. You know about the fiber, right? Fiber. Normally in the chicken, in the pork, and also in the rumen, they love fiber. in the chicken, we also love fiber. We also add the fiber in the feed as well. Why? The first one is when we add the fiber to the feed, it also increase the gizzard size, and also enhance for the nutrient utilization, and also change the microbiome of the bird because some fiber is act like a prebiotic, and also this one like a substrate for the bacterial fermentation. It also enhance for the immune system. And the last one, we have enhance for the GI tract development. We also enhance for the nutrient digestion. We also trigger for the immune system. That's why it also can improve the growth performance of the bird. So normally in the nutrition, we have two types of the fiber. So the first one is insoluble fiber. I love this one. For the chicken, I love this one. I think for the ruminant as well, you also prefer this one like a insoluble fiber. And also for the insoluble fiber, what is the mechanism of the insoluble fiber? The first one is enhance for the gizzard function and also the weight. I think that you can like imagine that in the chicken for the broiler it have like the gizzard. So when the gizzard is big, it means that the broiler is also big as well. Because the main function of the gizzard, this one for the digestion, not like a human, we use like a stomach, right? But for the broiler, they use the gizzard. That's why we should use the insoluble fiber to increase the gizzard size. The second one is it can produce the acidic condition in the stomach of the broiler. That's why it can enhance the digestion. The second one is can reduce pathogen colonization. This one is very important for the insoluble fiber. The dilation of the porticulus. So the broiler, they have like a 3 stomach, not like a human. We have only 1 stomach. In the broiler, they have 3 stomach, okay? The next one, I don't like this one. We talk about soluble fiber. I will show you later that the ingredient in Thailand contain a lot of soluble fiber. That's why sometimes it can make the issue. Why? The first one, increase the viscosity. The second one, when the digester increase the viscosity, it means that it can reduce the nutrient absorption. And also the last one, when the nutrient absorption is very low, it also increase the pathogen colonization. This one, I think that here, no nutritionist here, right? Oh, only Dr. Nartat. So this one is the enzyme that we use in the chicken feed. We have the phytase enzyme. This one like a basic one, the phytase enzyme. We have beta-glucanate enzyme. This one is also the basic one. And also the next one, silanate enzyme. This one also, we use this one when we use corn in the diet. So that's why we should add the silanate enzyme in the diet. We have like a manganese cellulose enzyme. This one is very important. And also the last one, protease enzyme. So for the protease enzyme, we use only in the young chicken. In the young chicken, I will show you the picture later why the young chicken, they need the protease enzyme. This one is the ingredients that contain the fiber. I mean like a soluble fiber. For example, the first one, arabinoxylan in wheat, corn, and also like in DDGS, beta-glucan in barley. We don't use barley in Thailand, we use in other countries. And also beta-mannan, this one in the soybean meals. We also use this one in Thailand as well. And also this one is the basic ingredient that we use in all Asia and also in other countries as well for the protein source. what happened? What happened about this photo? This photo is mean that we set the wrong feed formulation. In this feed formulation is contain very high weight, over than 50%, over than 50%. And also this one in the breeder hen, not in the broiler, in the breeder hen. You can see that the sticky poop, right? Very dirty in the breeder hen. And then what happened? If the breeder hen have the gut health issue, you can see the issue like this one. This one in the day old chick. The breeder hen have the gut health issue. They produce the egg and also the day old chick that we use to raise for the broiler to eat the meat. This one we call club down feather. Because the breeder hen, they cannot absorb vitamin B2. That's why it also can make the issue in the day old chick, in the broiler. That's why the feed formulation is very important. The fiber is very important. The benefit of the NSP enzyme that we use in the commercial feed. The first one, reduce the viscosity of the digester. This one is very important. The second one, improve the nutrient digestion. This one, I'm talking about protein, only protein, and also like energy. Normally, when we use the NSP enzyme, we can reduce the energy in the feed around 50 kcal. We can reduce the energy in the feed around 50 kcal. This one also can reduce the feed cost around 10 baht something, okay? And also, it also can improve the growth performance, the benefit. This one, it also increase the beneficial bacteria. And also, it can suppress for the pathogenic bacteria. That's why NSP enzyme is very important. If you want to produce the chicken feed, you should use this one. Organic acid. This one, I already list the name of the organic acid that we use in the feed. So, the key effect of the organic acid that we use in the feed. The first one is intestinal cell proliferation. This one like the gut health. The second one is antimicrobial. The third one is enhanced digestibility. So this one, the first one, the formic acid, this one is already used in the feed industry. This one we use to control salmonella. We use to control like a salmonella. That's why we use like a formic acid. The second one, we use to control the mold growth or the fungi growth. We use like a propionic acid. This one only 2 kilograms per metric ton is done. Enough for this one. And also the last one, the third one, I do not recommend. Very expensive. We talk about butyric acid. Butyric acid, this one is cannot control anything. Just enhance the gut health because butyric acid is the energy for the cell. That's why we add like a butyric acid into the feed. But I do not recommend this one. It's very expensive. And also the last one, citric acid. This one I do not recommend that as well. So if you want to use something to reduce the antibiotic, right? You just select the formic acid or propionic acid. This one is also very important. When we run the feed formulation, we should reduce the nutritional stress. What happened? When we give the bird very high crude protein, the crude protein cannot digest by the bird, cannot digest all, cannot absorb all, and also is produced like a nitrogenous waste. And also this one can increase the pathogenic bacteria. So that's why it can make the issue on the gut health as well. So that's why when we talk about requirement factor for the chicken, not only for the chicken, you can apply in the pig, in the tilapia, in the fish, in the shrimp as well. We talk about dynamic nutrient requirement. Dynamic, it means that day by day. or month by month or daily, right? The first one, genetics. My chicken, Betong chicken, have the different genetic, right? So it means that it's also require the different protein, different amino acid. The next one, the health status of the bird. The genders, okay, my question, between male and female broiler, which one require higher protein and amino acid when you run the feed formulation, male or female? Male or female? Male broiler require higher amino acid than female, around 5%. If you want to separate the feed, right, you should set the minimum amino acid like a higher than female, around 5%. The environment, I will show you later. The age of the bird also is very important. For example, like this one. This one is the recommendation for the chicken feed. You can see that for the chicken feed, when we run the feed formulation, we don't talk only for the protein. We don't talk only for the calcium, phosphorus, or everything. It means that when we run the feed formulation or we make the feed formulation, we run the feed formulation based on amino acid. And also these amino acid based on the digestible amino acid as well, not like a total amino acid. Even like a phosphorus level, we talk about available phosphorus. We don't talk about like a total phosphorus anymore, right? So that's why when the nutritionist, they run the feed formulation, they follow this one. And also another one you can see in that one that amino acid profile is also different as well. Last night I have the question from somebody that if we want to increase the breast muscle in the Betong chicken with amino acid, that we should increase in the feed. So the answer is we should increase the arginine level in the feed around 10 to 20%. And also this one is can increase the breast muscle around 2%, normally around 2% roughly, because it also depends on the genetic of the bird as well. What happened about this one? This one is the GI tract of the broiler chicken. And also you can see at the day one, right? Can you see the yellow color there? The yellow color there. The yellow color is mean that's why like a yolk of the chicken. They also absorb the yolk as well. So it means that for the broiler, even like you don't give them the feed 2 days, they can survive because they have the yolk like the yellow color. And also you can see that the yellow color like slightly disappear until day 7. So it means that they take the time for the yolk absorption. No need to give them the feed, right? 2 days is also okay, right? How about this one? This one is the idealistic of the temperature that we use for the broiler production. Idealistic. So normally the temperature for the broiler production is around silent, quiet, no feedback, no response. It's around 16 to 25 degrees Celsius. We should set the temperature inside the house. And also, I think tomorrow you visit the farm, right? Chicken farm. So normally the chicken, they love the cold environment between like a 16 to 25 degrees Celsius. And also you can see in this one that the bird look very happy. They walk like they walk on the lavender field, something like that. It's very happy, right? So that's why we love this one, the idealistic. This one is very idealistic. But in the reality, we have this one. Panting, right? We don't like this one. Normally we don't like this one. But this one is normal in Asia. Particularly in the summer season and also like a rainy season. So the bird like a panting, they have like a panting behavior. So that's why in the winter season, in the summer season, in the rainy season, normally nutritionists, they adjust the feed spec. They don't use the same feed for the whole year. It depends on the environment and also for the temperature as well. Okay, the last one, I think the last one. The health of the bird is also require the different amino acids as well. For example, if you want to enhance the growth of the chicken, you should increase total sulfur amino acid, threonine, arginine, or glutamine in the diet. If your bird have the issue on the gut health, you should increase total sulfur amino acid, arginine, and also like a glutamine. And also the last one, for the immune response, we talk about threonine. When the bird have like a panting, they have like a mucus, a lot of mucus, we should increase like a threonine in the diet because inside the mucus is also contain very high threonine. So that's why we should supplement threonine in the diet. Okay, not the last one. This one is the component of the gut health. I summarize to this one. The nutrition, we talk about the enzyme, the particle size. Okay, for the particle size of the chicken feed, normally we thought that very fine particle is very good for the chicken, but actually the coarse particle, it should be bigger than 1,000 micron for the chicken. So this one is good for the broiler. The non-digestible component, we talk about like a prebiotic, insoluble fiber, and also like a short-chain fatty acid. This one is very important. This one like a component of the gut health. So the summary of my presentation, the take-home message, antibiotic growth promoter, yes, we know that it have the benefit to improve the growth performance, to improve for the feed efficiency. But the one thing that they have the concern, the first one is overusing. The second one, residue. The last one is like a environmental condition. And also when we talk about like a nutrition solution, not only single, this one that I mentioned before, that holistic, many solutions that we should use in the feed, right? Gut health is the foundation I mentioned before. And also the last one, that don't complain nutrition need if your bird is not grow. You should go back and say and see that how about the farm environment, how about like a flock condition, how about like a disease as well, because that one is also impact on the growth performance. Thank you very much. It's a time for the lunch.
Thank you very much, Dr. Suhisak
Terima
Bunyang, for your
kasih.
valuable and insightful presentation.
ค่ะและลำดับต่อไปนะคะก็จะเข้าสู่พิธีมอบของที่ระลึกนะคะในก่อนนี้ขอเรียนเชิญผู้ช่วยศาสตราจารย์ดรสิริชัยนามบุรีอธิการบดีมหาวิทยาลัยราชภัฏยะลาค่ะได้เกียรติมอบของที่ระลึกนะคะให้กับท่านวิทยากรผู้ทรงคุณวุฒิทั้ง4ท่านด้านบนเวทีค่ะ
Ladies and gentlemen, may I now respectfully invite Assistant Professor Dr. Sichai Ramburi to come out on stage to present tokens of appreciation to our 4 distinguished keynote speakers. And may I invite our 4 keynote speakers on the stage. Ladies and gentlemen, Professor Dr. Chu Lei Chung.
ขอแสดงความยินดีด้วยค่ะ
Professor Dr. Rodolfo Cruz Silva.
ขอแสดงความยินดีด้วยค่ะ
Associate Professor Dr. Sukonraj Sukri Hayisame.
ขอแสดงความยินดีด้วยค่ะ
and Dr. Sudisak Bunyang.
ขอแสดงความยินดีด้วยค่ะ เรียนเชิญทั้ง4ท่านนะคะคีโนตทั้ง4ท่านถ่ายภาพร่วมกับท่านอธิการบดีค่ะขอเรียนเชิญค่ะ ทั้ง5ท่านยังคงอยู่ด้านบนเวทีนะคะเรียนเชิญท่านผู้มีเกียรติที่เคารพทุกท่านแถวหน้านะคะผู้บริหารมหาวิทยาลัยถ่ายภาพร่วมกันอีกครั้งหนึ่งด้านบนเวทีค่ะขอเรียนเชิญค่ะ
And may I invite our guests to come up on the stage for photo session, please. And our keynote speaker, please remain on the stage for photo session.
ค่ะเพื่อเป็นเกียรติในวันนี้นะคะสำหรับคีโนตทั้ง4ท่านนะคะผู้บริหารของเราภาคีเครือข่ายนะคะรวมทั้ง7หน่วยงานนะคะจะได้ถ่ายภาพร่วมกันอีกครั้งหนึ่งค่ะเรียนเชิญด้านบนเวทีได้เลยค่ะ ขอเป็นภาพใหญ่อีกหนึ่งภาพนะคะสำหรับวันนี้หลังจากที่เราได้รับฟังการบรรยายพิเศษกันไปเป็นที่เรียบร้อยทั้ง4ท่านค่ะขอบคุณท่านอธิการบดีนะคะขอบคุณคีโนตทั้ง4ท่านแล้วก็คณะผู้บริหารเครือข่ายของเราทั้ง7ส่วนแล้วก็ภาคีร่วมในวันนี้ทุกๆท่านอีกครั้งหนึ่งค่ะค่ะในช่วงเช้านะคะสำหรับพิธีเปิดนะคะอย่างเป็นทางการสำหรับการประชุมวิชาการนานาชาติ AWIS 2026นะคะในภาคเช้านะคะก็คงจะไว้เพียงเท่านี้นะคะส่วนภาคบ่ายค่ะในวันนี้อาจารย์บิ๊กคะมีอะไรบ้างคะในภาคบ่ายเราจะมีการนำเสนอในส่วนของผลงาน
ครับ
ตามห้องต่างๆนะคะอีกครั้งหนึ่งแล้วก็ในช่วงเย็นก็จะมีการมอบรางวัลนะคะให้กับผู้ชนะเลิศในการนำเสนอผลงานในครั้งนี้กันด้วยนะคะสำหรับชั่วโมงตรงนี้นะคะดิฉันปัทมาเนียมบดีนักประชาสัมพันธ์ชำนาญการงานประชาสัมพันธ์และมวลชนสัมพันธ์ค่ะ
And I'm already present your serial lectures of English and Linguistics from Faculty of Humanities and Social Sciences.
ค่ะเราทั้งสองคนต้องขอบคุณทุกท่านอีกครั้งหนึ่งนะคะสวัสดีค่ะ
ครับสวัสดีครับ